Good morning, students. First of all, let me wish you best of luck for your third unit exam. Now, we already know that we are doing the 11th chapter, that is recursion, and we have already done few problems in recursion. Now, today I will end with recursion and I will start a new chapter. But before ending recursion, one small topic is left, that is the comparison between recursion and iteration. So see, iteration means what? Iteration means whenever we are solving something via loop. This type of thing is known as iteration, and recursion means with repeated, means whenever we are solving some problem with repeated function call. So generally both of them are related concepts, and anything you can do with a loop you can also do with a recursion, and obviously the opposite is also correct. But sometimes it may appear that it is easier to use one method over the other method. Okay, like for factorial we generally go for loops, but for tower of Hanoi problem it is better to go for iterations. Means it is better to go for recursion. Now, when a loop repeat, it uses same memory for variables and repeat the same unit of code. Okay, but when we are doing with recursion, instead of repeating the same unit of code and using the same memory location for variables, fresh memory space is allowed for each of the recursive calls. So what happens? Because of the extra memory stack manipulation, recursive version of functions often run slower and use more memory than their relative counterparts. But this is not always the case, and recursion can sometimes make code easier to understand. You can understand by the Tower of Hanoi problem only that it is easier to solve with recursion than iteration. So any problem that can be solved via iteration can be solved using recursion, and any problem that can be solved via recursion can be solved using iteration. Now, iteration is preferred by programmers for most recurring events, reserving recursion for instances where the programming solution would be greatly simplified. Now, in a programming language, recursion involves some additional costs in terms of space used in RAM by each recursive call to a function and in time used by function calls. Okay, so this is some comparison between recursion and iteration. Hope you understood the things, and as I told you in other chapters that you should follow the examples given at the last of the chapter as well as the solved question answers. Then you need to follow the means whatever is given, means let us recall or something like that, means some points given at the end of the chapter you need to follow through these things. So that much in this chapter. We are not proceeding further. Okay, now next we will start with a new chapter that is called inheritance. Now that is chapter number 12 in your book. Now first let me give you some idea about inheritance. I know that you have already some idea about inheritance, but then also let me tell you that we are using a class car in our previous examples. Okay, now this car class is inherited from other class automobile, which again is inherited from other class vehicle. Now inheritance is a property in object oriented programming where you can use the some of the properties from your parent class. Okay, just like suppose there is a parent class and from there we are deriving a new class that is called child class, so that child class can access some of the properties from parent class. Okay, so the most important advantage of inheritance is reusability. Reusability means what? Reusability means something is already written. If you want to add some extra feature, you can add it to it, this. Okay, so reusing existing code, it saves the money, time and effort and increases the program's readability. Now without defining the old class, you can add new property to the derived class. Okay, so this is some basic idea about inheritance. Now let's see the next page. First of all, it is given what is the need for inheritance. See, as I told that reusability is the greatest advantage or greatest need. So here see point number 2, reason for this idea of reusability. Inheritance allows the addition of additional features to an existing class without modifying it. Remember, without modifying it. Now one can derive a new class from an existing one and add new feature to it. Now suppose here is an example given that a class is there, person. Just a minute. A class is there, person, and from that class one class is inheriting, that is student, and from there one new class is inheriting graduate student. Okay, so every graduate student is a student. That is the meaning of that. So this thing is known as reusability. Next, point number 1, see, the major reason behind this is the capability to express the inheritance relationship, which ensures the closeness with the real world model. So by using inheritance, we can express the problem better with the closeness with the real world model. Okay, and next one, inheritance is transitive in nature. Transitive means, let me tell you, suppose A inherits B and B inherits C. So I can say that A inherits C. Okay, here is an example. So you just read the example that suppose we inherit B from A, the class C and D inherit from B. Okay, so A, then from A B class is coming, and from B C and D both classes are coming. Okay, now suppose there is a bug in A or error in A. Now after correcting the bug, it automatically reflect to all the classes that inherit from A. Okay, if the class A has been inherited without change. Now see the reduction in amount of effort that one would have done if each class inherit from A was to be modified separately, is gifted benefit of being transitive. So thank you for today.